So, super real, like very quick. Uh, Basically, what you're going to start looking at is what if a relation is nonlinear, meaning it is not a straight line. That's all you've done in grade 9, and that's all we've been doing so far. So, all those things that you were factoring in the last unit, we're going to graph them. We're going to see what they look like, and you're going to notice that it is a curve. It is not a line. So, even just looking at like a scatter plot with some data points, you know line of best fit, right? You've talked about line of best fit before, right? Grade 9? Yeah, where it's like if you have a bunch of points, what is like the line through it that like best models that data? Sometimes it's a curve. So like if I wanted to hit all of these points, I could probably draw a curve something like that. And that would be like the best curve, right? What would I draw for this one? A curve, a line? What do we think? I think a line too. I'll go straight through. Yeah. I do not have a pencil sharpener. Does somebody have a pencil sharpener? Wow. Thank you, Isa. Same thing. I think I could draw a line through this to hit all the points. What about this last one? I think a curve too. Something like that, right? To hit all the points. Right? So sometimes it's not a line to do a best fit, right? Even with these ones, it's just getting you to identify which one's a line and which one's not a line. So we were just calling it nonlinear. So this one to me looks like a line. Second one, line or curve. Not a trick question. Line, right? This one, not a line, it curves. So we can say that this is a curve, right? And then the last one, that is a straight line. So this is a line of best fit, right? Then sometimes you will have to plot the data to determine whether you're going to need a line of best fit or a curve of best fit. So even I'm going to make a table for this. And our scenario is a Jeep driving a certain distance over a certain amount of time. So from 0 to 14 seconds. So I'm going to make my axes here. Which one is time going on? The vertical one or the horizontal one? Do you remember? Vertical or horizontal one? Where's time going?
Horizontal one.
The horizontal one? Why do you think the horizontal one?
It shows like the time like changing all the time.
Time is an independent variable. Like time doesn't change. It's just this constant ongoing thing. Like time's going on right now. It went from 1:14 to 1:15. I can't change that. I can't go back in time. I can't go forward. So that will be our x-axis. Whereas distance, right? That is dependent on time. How far we go is dependent on how long we're driving for, right? So that one will be the dependent or like the y-axis, right? So time, independent, distance, dependent. And I'm gonna have to make a scale now. So I think I'll do like 2s for my time. So 2, 4, 6, 8, 10, and 12. That's everything I need. And then I've got big distance. I go all the way up to 225. So I'm thinking maybe we got to do like 25s to go up by. It's okay. 25, 50, 75, a hundo, 125, 150, 175, 200, and then 225. So perfectly fits. And now we just got to plot these points. Right? Because our scale is so big, let's just try to be as accurate as possible. So starting 0, 0, that's like this little corner here, right? So 0, 0 is there. Then after 2 seconds, I've driven 10 meters. So okay, at 2, I'm going to roughly estimate that 10 is like maybe about there, roughly. Right? At 4 seconds, I'm at 20. So again, I'm getting closer to 25, but not quite touching it. And then I've got 6 at 50. So, okay, 6 at 50. 8 at 100. So I'm here. 10 at 160. So again, a little after 150. I'd be like maybe about there. And then lastly, 12 at 225. So I'm all the way up here. Is this a straight line or is it kind of curvy? It's just kind of curvy, right? So you'll see it kind of exponentially grows like that. If I drew a straight line through it and just do your best to trace, sometimes these get a little wonky. right? It's not a straight line, because it's like with a straight line, the whole point of slope is that you are increasing or decreasing by the same amount every single time, right? So when we did slope, we would do like over 1, up 2, over 1, up 2, over 1, up 2. So we were increasing by 2 every single time. But you can see, like, I am not increasing by the same amount every single time. I went from 0 to 10, 10 to 20, but then I went 20 to 50, so I went up by 30, and then 50 to 100, I went up by 50, and then 100 to 160, I went up by 60, so I'm going up by different amounts every single time. So it can't be a line. Is that okay? That concept? Cool. That's it. I'm good to flip? Okay, so that is what makes a quadratic relation. So that's the word we're using now, quadratic. And it's a relationship between x and y, and it's in this relation, y equals ax squared plus bx plus c, which you know how to factor. That's what we did this whole last unit. And it makes this parabola-shaped graph. I like to think about it as a smiley face, because it's smiling with some dimples, right? So it's that U-shaped graph. And the last thing that we were doing in this lesson is looking at finite differences, which I think you did last year with lines. And you talked about first differences being the same, right? So it was like the idea of like, if you subtract your y coordinates from each other, the first differences will be the same. With a quadratic, its second differences are the same. So even looking at this one, this is a line, and I'm gonna take my bottom one and subtract it from my top one. And I'm gonna do 4 minus 1, which gives me what? 3, right? And I'm going to keep repeating. 7 minus 4, which is also 3. 10 minus 7, 3. 13 minus 10, also 3. And you'll see this is 3 every single time. Why I didn't do the reverse and do like top minus bottom, I would have done then 1 minus 4. Which gives me negative 3. And if I look at my y values, am I decreasing by 3 each time? No, I'm increasing by 3. So if I were to do the opposite flip, then it would be saying that my line's decreasing, not increasing, right? So that's why we do like the second point minus the first point. Moving on to our quadratic, right? 2x squared minus 1. We're going to see, okay, 7 minus 17, that gives me negative 10. Then I go to the next one, 1 minus 7, that is not 10. That is negative 6. Same thing, negative 1 minus 1, negative 2. 1 minus negative 1, what's that going to give me? 1 minus negative 1, 2, exactly, because it turns into like 1 plus 1. And then same thing, 7 minus 1, 6. 17 minus 7, 10. So they are not the same. Those are all different numbers. Do you notice anything about those outputs? Yeah, what do you notice? They're increasing by 4 each time. Okay, which we're going to see in the second one. What else do you notice about them? Do we see any kind of pattern? Yeah, Jordan? They're repeating or they're flipped, or we could say it's symmetrical. So like this is the flip point right here where it's 10, negative 10, negative 6, negative 2. And then you notice it's 2, 6, 10. So it's the same numbers, but signs flipped because we see, who's your friend there? Who's there? Oh gosh. Tell him to get his own classroom. Right? If you look at this parabola, see how it's like mirrored on each side? That's the idea, that you'll have that symmetrical line. So you'll have the same points, just different signs, right? So now, okay, if I'm doing the second differences, negative 6 minus negative 10 is what? I heard it. Oh, Christina, 4. Same thing. Negative 2 minus negative 6, also 4. I think Ethan's onto something. 2 minus negative 2. Also 4, and you'll see that this works out for everything. 6 minus 2, 4. 10 minus 6 is also 4. So because the second differences are the same, it is quadratic. If the second differences were not the same, let's just say hypothetically, we would say it is neither. It's neither a line, it's neither a quadratic. That's above grade 10 pay grade. That's when you're getting into advanced functions, like level stuff of third differences or fourth differences being the same. So we're not going to do that. So it's either first differences are the same, second differences are the same, or neither. It's okay. Do y'all want to try 4 on your own and see if you can determine whether or not this data set is a line, a parabola, or neither of them? Yes, we want to. Try it on your own. Or if someone wants to do it on the iPad, you can have iPad time. Do you want to do it? You want to try it? Okay, you do one and then you do one? Okay. You want to do it? Yeah. You are. Have the comfy seat. Look, I left my Stanley in the other room. Okay. Okay, so lead us through. What are we doing? So what do we get? 3 minus 1. You can zoom in if you like. There's a calculator right here if you want to check. Okay, first one. Next, we've got 5 minus 3.
Okay, I'm having a hard time writing this.
That's okay. You can zoom in. Your palm can touch it. It has palm rejection. Okay, don't crack the screen.
Okay, so 3 minus 1 equals
2.
5 minus 3 equals
2.
7 minus 5 equals,
Also 2.
and 9 minus 7 equals.
So what does it mean?
Do we
First
guys-
differences
oh.
are the same. Is it a line or is it a parabola or neither?
Yeah, it's a line. Do we agree? Yeah, that's what I thought.
Okay, perfect. So
Check
you can
mark.
say line or linear. Perfect. Thank you, Jordan. Okay.
Oh, you're welcome.
Ethan P. Mr. Pap, you're
Oh.
up.
Low power, mommy.
Okay, here you are.
Can I make a guess right off the bat?
Sure.
Indifference? It's gonna be a quadratic.
Okay, you think it's going to be a quadratic.
Yeah.
What Spidey sense is telling you that? Like, why do you think that?
Because it's the same. Look, these are all the same, just reversed.
So he's looking at already the y values being like, oh, it's inverted.
Yeah, and so
5,
are
2,
the
1,
so are
1,
the
2,
x
5.
values. Oh,
Right, so okay, let's prove it with second differences.
yeah, these are all the same. So
Okay, let's prove it with second differences. Hello, how's it going? Okay, we got 5 minus 2, 3. Ooh, we gotta do the flip. Remember, bottom one minus top one, so 2 minus 5.
oh
You
yeah,
did
you're
it
right.
right here. You did 1 minus 2 in the second one, but just the top one has to be 2 minus 5. Finite differences. I don't see finite differences there. I can't see in your head. You have to show finite differences.
You have to write mine? I can't write what?
Oh no, equals.
2 minus 1, 1. Oh! 5 minus 2. So first differences, not the same. Right? But what
Yeah.
about second differences? So now we're going to do
What
these
negative?
brackets. Exactly. -1 minus -3. It's going to give me what?
-1 minus -3. That's 2.
Voila, look at that. Second differences are all 2. So is it linear, quadratic, neither?
It is.
Jeez. Quadratic. Bam.
Don't know if you
That's
can
it for
read that.
you. That's literally the whole lesson. It's your little intro, tiny intro. Homework is already posted on the Google Classroom, so try some practice problems. And once you're done those, study for your test. That's it. I told you it was a little baby lesson. I promised. Yeah, and it's 1:05, so this class ends at what, like 2:05? 2:05, 2:10-ish? Okay. So that's what we're going to work on for this time. Remember, cell phones are not our friends. If you're using it for educational purposes, like to look at the Google Classroom.